All right. When you're doing, pause real quick. All right. So when you're doing limits, your first approach number one is just plug in the number and see what happens. So these first few, I made like that. We're just going to plug in 3. And so you get sine of pi over 3. And so this is more a pre-calc question than a calculus question. We're just going to do our unit circle. Remember I gave you that unit circle the one day? And oh boy, okay. Yeah, so you're going to go ahead and put that away. You don't get that on the AP exam.
You don't get it on the AP exam? I'll make one. We'll make one.
You take out your earbud. No, you don't get anything on the AP exam, right? You should not eat 1/3 of pie. That's too much pie. You will have a stomach ache. Do you remember how we talked about large, medium, small? Okay, so pi over 3 is the biggest one. Remember, big side goes across from big angle, medium goes across from medium, small goes across from small?
Yeah.
All right, what is the largest side option that's going to go across from that? Square root of 3 over 2. It goes 1, 2, 3. Small, medium, large. So that means the other side is 1/2. The triangle, and some of you didn't draw it, the triangle is your work. You must show your work. The triangle is your work. A triangle has 3 sides. Work with me. All right? That's your work. When I teach pre-calc, if you don't have a triangle, I mark it completely wrong. It's your work. Okay? Sine is which part of that? The y value, which is square root of 3 over 2, so that's your answer. So it's more a pre-calc question than a calculus question. Let's just try it again. This one says from the right. That doesn't really matter in this case. You're just going to plug in 4, and you get cosine 4 pi over 3. Now, this isn't in quadrant 1. Do you remember what quadrant 4/3 is in? And give it a think before you just shout out, an answer. It is in 3. 3/3 would be 1 whole pi. 4/3 means you just rotate it a little further than that. So your angle is still pi over 3. And so across from that, square root of 3 over 2, except it's negative. Good job. The other side is 1/2, but also negative. That is your work. Cosine is which part of that?
The negative 1.
Yeah, good. The x part, so negative 1/2.
Wait, so sine is y, cosine is x.
Correct.
Okay.
Yep. And if you want to think of it this way, what it comes back to is, do you remember SOHCAHTOA, opposite, adjacent, hypotenuse? If this is your angle, the opposite side is y. Sine is opposite over hypotenuse, but since it's a unit circle, the hypotenuse is 1 unit. So opposite over hypotenuse, y over 1 is just y. X over 1 is just, so it comes back to SOHCAHTOA, like from geometry, right? So this one, we're going to do secant of 5 pi over 6. I'm going to pause. I want you guys to try it with your partner. Like a good attitude. All right, what quadrant did you put this in? 2. All right. And your reference angle is pi over 6. Now a 6 is a small slice. That's a normal amount of pi to eat. Okay. Yeah, but our reference angle is just pi over 6. That's the reference angle. So across from that, you put the small side, which is 1/2. Small goes across from small. Other side is square root of 3 over 2, but it's negative. Okay, that is your work. Now we answer the question. Secant is the reciprocal of cosine. Cosine is the x. So we're going to flip the x coordinate. All right, so it's going to be negative 2 over square root of 3, and then you have to rationalize. So negative 2 square root of 3 over 3 is your final answer. Did anyone make it the whole way through? But you got to here? That's good. I feel like if you got to here and it was multiple choice, you would probably be able to pick A, B, C, or D. I believe in you. You multiply by what that denominator is. Someone somewhere decided you're not allowed to have a root in the denominator. So we rationalize. If you multiply the numerator and the denominator by square root of 3, yeah, so that you don't have a radical in the denominator. I don't know why that's the rule, but it is. So. Square root of 2, yeah. And then you end up with just 2 because they cancel out. Good. I'm going to say what I'm going to say. You can deal with it or not. I'm going to direct you to that sign once again. You're never going to see that as an answer choice, ever, ever, ever. So I'm going to go with no, don't do that. Okay, but I have a question for you. Why would you give yourself a negative exponent and a negative fraction exponent at that? That's like, let's make it as complicated as possible. All right, I'm going to move on. These next two, 16 and 17, I want you to put a star next to. They aren't problems that we're going to work out. They are properties. I'm going to tell you what they are, and then you use the property to answer other questions. When you see limit x goes to 0 of sine of x over x, that equals 1. On your own time, if you want to throw that into Desmos and look at it, if you don't trust me at this point, then you can do that. You can also reciprocate it. So if it's x over sine of x, same thing. It'll come out to be 1. Okay? So this one, limit x goes to 0. 1 minus cosine x over x, that equals 0. Again, if you want to put that function into Desmos and look at it and see it approaching 0, you can do that on your own time, or you can just believe me. It's true. Okay. So when you look at this one, do you see the sine of x over x in there? Kind of like I'm circling it, but it looks more like a jelly bean, right? That part goes to 1. So your answer is good. Perfect. Nice job. I like the it's like we're thinking about it. Yes, go ahead. Yes, so if you reciprocate this, same thing. It's still just 1. No. I would have said that if it was. I will always be thorough and explain it all to you. You can't reciprocate this. But good question. All right, so for this one, I'm going to go through mathematically how it's supposed to be, but what do you think the answer is going to be? You're correct, but here's why that is. You would multiply the numerator by 5 and the denominator by 5. And here's the part that would get circled. You have sine of 5x over 5x. That part has to match. So sine 5x over 5x. But if you come across something like this on an AP question, what do I expect you to do? Just put 5/7. Do you get what I'm saying? Like, let's not overcomplicate things. But mathematically, that's why that works. Yeah, it is a little scary. So, when that happens, what I want you to do is go, okay, this one's a little scary. Take a few deep breaths, step back. The problem's not going to jump off the paper and chase you, okay? At the end of the day, it's going to be all right, okay? Now, this one's going to involve a little bit more work, so the first thing you're going to do is write limit. You need to keep that. If you leave off limit, it's no longer calculus. You turned it back into algebra, or in this case, pre-calc, but it's not calculus. Okay? What do you notice both of these terms have in them? Sine, right? Sine. Neither of them has a plain old x. It's sine x. So that's your GCF. You're going to take out sine x and see what's left. The purpose of a fidget is to help you concentrate better, not worse. So if it is helping you concentrate better, then that's valid. If not, then it's not. So if you undistribute sine x, what are you going to be left with? 1 minus cosine x. Now the denominator, I'm going to write it like this. It means the same thing, 9x times x. The reason I did that is so you could see the property, 1 minus cosine x over x. Let me finish my thought now. Or are you going to answer this? Okay, hold on a second. What does that equal just by definition? 0. 0 times anything is 0. So that's your answer. Go ahead.
Negative one. Because the negative sign x.
Are you saying you want to put a 1 right here?
Well, the initial problem, like a pop, was sine x minus sine x cosine x.
Correct.
And sine x didn't work out with cosine, or negative sine.
Yeah, I kept the negative. It's right here.
What was it before the one?
No.
Well, you're factoring. Well, I mean, multiplying like that one.
Then I'm just saying,
But how do you?
sign, or sign X.
I got you. I got you. Hold on. I'll show you. You're dividing this by sine x, and you're dividing this by sine x. Oops. I'm sorry. There you go. So this part is just positive 1 minus cosine.
Okay.
Visually, does that help better? Do you see how sine over sine is just 1, positive 1? Just 1. Think a little bit less.
Yeah.
Here's my suggestion. Cool? Good so far?
Then you do that.
Then don't look here. I got rid of it. Good, it's gone. Didn't happen. Do.
That makes sense.
Remember, guys.
I feel like I've lost everyone now. What can I do to get us back on track here?
You may want to go over it and multiply 1 minus cosine x by sine of x, and you just get sine of x minus sine of x cosine.
Whatever you just said, right?
Okay, we're gonna move on. If you need more clarification on problem 20, you can let me know at the end, okay? Here, we're gonna start by plugging in pi over 2. You always just plug in the value and see what you get. That's gonna give you 4 over, now we're gonna use our imaginations. On your unit circle, where is pi over 2?
Or not.
We don't do degrees.
Between.
Hit the top. Up is the word I was like, let's use words like up, down, left, right. We'll try again. Where's pi over 2? Up. Tippity top. All right, what's the coordinate?
0,
0, comma 1. Cosine is the x part, which is 0. What does this mean your graph has in it? If you get a value over 0, asymptote. So you can only get an answer if it's sided. Is this one sided?
No, it is.
It is. Our answer is either positive infinity or negative infinity. All right, so at this point, you got a 50-50 shot. I like to think through visually. So I think you're right, but I'm going to just draw it real quick. Cosine starts here at 0, 1 and does this wave. You don't need to draw the whole thing, and you don't even need to be very specific about it. It's just to get a visual. Or if you have a really great, vivid imagination, just imagine that in your head, okay? Are we approaching pi over 2 from the left or right? Left. Okay, so watch. I'm going to just point to this. Look at. Here's pi over 2. If we approach from the left, is this graph above or below the x-axis? And I call it above sea level and below sea level. You'll hear me say that. Don't write that on your AP exam. I had someone write above sea level on a test once, and I marked it right, but they will not on the AP exam. They will just laugh at you, okay? Above the x-axis means positive. So these values are all positive. And 4 is obviously positive. So our answer is positive infinity, gone up. Yes. And it means from the left side, the graph is going up. All right. If you're like, hey, I didn't quite get that, we're going to do another one just like it. Go ahead.
So like, if you wanted to solve that without writing in the graph, you would have to plug in like a value.
Yes, but that becomes tricky because a lot of people don't. It's just harder that way. I think visually is easier, but you're right.
Is it? It's like, I guess it's like cosine.
Yeah, so if you plugged in the number to the left of pi over 2, like pi over 3 or something, and then evaluated that on the unit circle and see, yeah, I think you're right.
I guess just.
Yeah, you're not wrong. I just think this way's easier. All right, so pi, using a word like up, down, left, right, where's pi on your unit circle?
My left.
Left, okay. That's the coordinates. -1, 0. Sine is the y value, so 0. This means asymptote. This means you can only get an answer if it's sided, but it is. Okay? So I'm going to just real quick draw a picture of sine of x. It doesn't need to be super complicated. Cosine starts up here at 1. Where does sine start? Yeah, at 0. So it's going to do something like this. Here's pi. Are we approaching from the left or the right? Now, if you approach from the right, where are these values? Under sea level. That's negative. -2 is obviously negative. So positive infinity. Beautiful. You guys got it. Nice. You got there. That's about as hard as I can make it. All right. For this one, I can either talk you through this every last step of the way, or I want to see if anyone remembers what I said last time. If you are not sure what to do and you see a natural log in a limit, what did I say your good guess was? Because the natural log graph is not very interesting. Negative infinity. What does the graph of natural log look like?
Negative infinity to one.
Is a good sound effect. It's a swoop, right? A sideways swoop. The only interesting part of it is the asymptote. The rest of it's super boring. It's continuous. There's no breaks, there's no holes, there's no gaps. It's a really boring graph. The only interesting part about it is negative infinity. If you want a more in-depth answer or like explanation to that question, we'll do that one-on-one another time. I don't want to lose everybody. But if you see an LM with a limit, what's a good guess? It's the only interesting part of the graph, all right? And then here we have piecewise. For this one, I want you to go ahead and take a second and just put some lines in here so you can tell which part is which. This is broken into 5 pieces. We are going to refer to them as 1, 2, 3, 4, 5, so that we can talk about them. So we can communicate effectively, like which piece of the function, 1, 2, 3, 4, 5, that's how we'll call them. All you have to do with piecewise limits is make a decision. I get that decisions can be hard. Which piece of the function are you going to plug into? Where does -3 live? Yeah, so the first one, right? All you're going to do is plug -3 into that. What do you get? Perfect, that's it.
Yeah.
How about 5? Which piece of the function does 5 live in? Yeah, bigger than 2, so the last one, right? So if you plug 5 into that, yeah, weirdly it's -1/9, but that's just, how it turned out. All right, 3 halves. That's 1 1/2, 1.5. So which piece of the function? Number 4, all right? 3 halves plus 1, 5 halves, good. Or 2.5. Do you guys like decimals or fractions better?
Yes.
I'm kind of a fraction person, but it does depend on the problem. I'm just curious. All right, now we're going to start approaching where the cuts in the piecewise function happen. Go to -1 from the left. You want to find which piece involves numbers to the left of -1.
It's just two.
Left of -1. Do you see how this first part is left of -1? So you're just going to plug -1 into that. But Miss Cole, it's not there. It's a limit. A limit is behavior. It's just where you're headed.
Yeah, it's even pointing to the left.
Yeah, oh, it is pointing left. Okay. So if you plug -1 into that, what are you going to get? 1/1, 1. All right, -1 from the right. You want the piece of the function that involves numbers to the right of -1. Yeah, it's the second one, which is just literally the number 2. It's constant. Now, you don't even need to look at this anymore for the third part, bless you. If the left goes to 1 and the right goes to 2, what is the overall? DNA does not exist. And what kind of discontinuity would there be there? Use your imagination. This side goes to 1, this side goes to 2. Jump, is that removable or non-removable? Non-removable. Good job, guys. Perfect. Removable is like you just removed a point. If it's actually broken and you have a gap, you can't fix it by just putting a point back in. Yeah, a hole would be removable because you just removed it. Not like that at all. No. All right. Now we're going to approach +1 from the left. Which piece? I'm looking for a number like 1, 2, 3, 4, 5 is numbers to the left of 1. Yeah, good. Oh, and actually the answer is just 2. All right. Numbers to the right of 1. 4. So if you plug into that one, 1 plus 1, you see the math. Then I'm standing in front of a BC calculus class going 1 plus 1 is 2 because it's the math we're doing. Now you don't even need to look at the function anymore. Left was 2, right was 2, so the overall answer is. I don't appreciate that because I'm trying to keep it. It's my job to make sure everyone understands, and that's derailing my job. So we're going to try that again. The left is 2, the right is 2, so the overall answer is 2. Cool. There is a discontinuity there, though, because the actual point is at 3. That's I tricked you, I stole the point, now it's over here, so that is removable. Okay, it would look like this.
Oh.
Okay, the limit goes to 2, but then the actual point is up there at 3. Okay, all right, 2 from the left. Which piece involves numbers left of 2? The fourth one, good. Plug in there, 2 plus 1, 3, cool. 2 from the right, that's the last one. This one's a little bit more complicated, just as a heads up. It's going to be -1 over, what does that mean the graph has? Asymptote. Can we get an answer or not?
Yeah.
We can't. Pick a number to the right of 2. So, can we talk about that real quick? A limit means you need to get very, 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 very close to the number that you're approaching. So 18 is not going to work. 3 is good. Okay? Or yeah, but I wouldn't plug in a decimal, but I digress. 18 it would not be a good choice. Okay? The behavior is not the same in that part of the graph. You have to stay local, right? So if you plug in 3 minus 2, 1 square, I guess it doesn't matter. It's squared. It's going to be positive all the time. And then -1 is obviously negative. So negative infinity. Now, if the left is 3 and the right is negative infinity, yeah, I don't think that that's going to match up there.